Assalamualaikum and hi everyone. Today we're going to learn Chapter 2 Inequalities and Absolute Values. The first subtopic, which is inequalities. What we're going to learn in these subtopics are the first one, the properties of inequalities. The second one is intervals, solution sets and number line. The third one, union and intersection with the aid of number line. The fourth one, linear and compound inequalities. And the final one is solving quadratic inequalities using graphical approach. For the second subtopic, absolute values, the first thing we're going to learn is the properties of absolute values. The second one, we're going to learn how to solve absolute equation. And the final one, we're going to learn how to solve absolute inequalities. At the end of this lesson, you should be able to A. Relate the properties of inequalities. B. Represent intervals, solution sets and their representations on number line. C. Determine union and intersection up to 3 intervals with the aid of number line. 2.1 Inequalities. What is inequality? Inequality involves the sign of greater than or equal to, less than, and less than or equal to. Let's learn how to relate the properties of inequalities. If A greater than B, then A plus C is greater than B plus C if C is positive. So if we have 4 greater than 3, then if we add positive 2 on both sides of our inequality, we're going to get 6 is greater than 5. Our inequality symbol here doesn't change. If A greater than B, then AC is greater than BC if we multiply both sides of our A greater than B with a positive C. So if we have 4 greater than 3, then we multiply with a positive 2, then we're going to get 8 is greater than 6. The inequality sign also doesn't change. But it's going to be the opposite way if we multiply A greater than B with a negative C, where AC is less than BC. So if we have 4 greater than 3, then we multiply both sides of our inequality with a negative 2, then the symbol of our inequality is going to change, where negative 8 is less than negative 6. If A greater than B, then if we divide both sides with a negative C, then A over C will be less than B over C. So if you have 4 greater than 3, we divide both sides of our inequality with negative 2, then the symbol of our inequality will be changed, where negative 2 is less than negative 1.5. If A greater than B, then 1 over A is less than 1 over B, where A and B is not equals to 0. So if you have 4 greater than 3, 1 over 4 is less than 1 over 3. As the conclusion, it's either you have less than or equals to. The smaller value will always be on the left hand side and the bigger value will be on the right hand side. Vice versa if you have the symbol greater than or equals to. Now let's move on to how to represent intervals, solution sets and their representations on the number line. What are the notations that we're going to use on a number line? This is an open circle where we're going to use to exclude the real value. This open circle is used for the symbol less than or greater than. This symbol is called closed circle, where we're going to include the real value. This symbol is used for the symbol less than or equal to or greater than or equal to. This is a right side arrow where we're going to include all real values that approaching to positive infinity. And we're going to use with the symbol greater than or equals to. So we have the opposite arrow, which is called left side arrow, where we're going to include all real values approaching to negative infinity. This symbol is used with the symbol or the inequality sign of less than or equals to. The final one, this is a straight line where we're going to use for all real values that lies in between two numbers, such as x is greater than a and x is less than b. Let's say a and b are real numbers. We're going to use two inequalities here. Either it's going to be the same sign, less than and less than, or both have less than or equal sign, or either one will be less than or equals and the other will be less than, or the vice versa. Let's take a look of an example. We have a closed circle on top of -1 and 0. This means that we only include -1 and 0. Now we have a closed circle on top of -1 and open circle on top of 1. We're going to connect these two circles with a straight line. What does this mean? This means that we're going to include all real values such as -1, -0.67, 0, 0.3, half, 0.972, and so many more. This is an open circle where we're going to exclude the value of 0. It's probably started with, let's say, 0.001. And let's connect this open circle with an arrow, a right side arrow. And this right side arrow means that a real values that approaching to positive infinity, such as half, 0.99, 1.5, exponent, or probably 10 million. Let's take a look on the type of interval, solution set, and representation on the number line. We have 4 types of intervals. The first interval is closed interval. We can denote a and b with a square brackets, where a, which is the smaller value, will be on the left and the larger value, b, will be on the right. You may say a is the start point and b is the end point. For the solution set, we write pretty much the same as interval notation, just a few change. We use open curly bracket, x, a colon, another x in the middle of a and b, and close curly bracket. Now we read it as x is such that x greater than or equals to a and x is less than or equals to b. Now the number line, since we're using the square bracket and the inequality sign of less than or equals to, so on top of A is closed circle, same goes for on top of B, another closed circle. And we're going to connect these two circles with a straight line. Now let's take a look of an example. Let's say we have a closed interval of 2, 5. X is such that x is greater than or equals to 2 and x is less than or equals to 5. The number line on top of 2 is a closed circle, and on top of 5 is another closed circle, and connect these two circles with a straight line. The second type of interval is open interval. Well, the difference between closed and open interval is for open interval, we're going to use round bracket for both sides of A and B. For the solution set, we're going to use the symbol less than. And for the number line, we're going to use open circle for both A and B. And here is the example. The third type of interval is half open interval or half closed interval. It's kind of mixture of interval like yin and yang. Just kidding. One with a round bracket, the other one is with the square bracket. So the solution set will be expressed as x is such that x is more than a and x is less than or equals to b. So we're going to follow the bracket that we write down just now, which is for the round bracket, we're going to use less than, and for the square bracket, we're going to use less than or equals to. For the number line, we're going to use empty circle because we're using the round bracket or less than. And for B, we're going to use closed circle because we're using the square bracket and less than or equals to. Then let's connect these two circles with a straight line. Now take a look of the example. This example is pretty much the same as just now, the half closed interval, where I just exchanged the square brackets on the left and the round brackets on the right. So the symbol of less than or equals to b will be on the left and the symbol of less than will be on the right. So does with the closed circle and open circle. And this is the example. The fourth type of interval is infinite interval. Let's say A is included, so we're going to use a square bracket, and we also would like to include all the real values on the right side, so we're going to represent it with infinity or positive infinity. When we write such, we are simply referring to the interval starting at the A and continuing indefinitely to the right. We only use a round bracket for infinity. Remember that A is smaller, so that's why it is written on the left hand side. For the solution set, we're going to write down as x is such that x is greater than or equals to A. For the number line, we're going to represent A with a closed circle, and for positive infinity, we're going to use right side arrow. Now let's take a look at the example. This one is pretty much the same. It's just that we're going to exclude the value of A. So we're going to use greater than and also empty circle. Another example of infinite interval. Now the negative infinity will be on the left, and we're going to include the value of B, then we're going to write down on the right. So always use a round bracket for negative infinity. Since the negative infinity is on the left, therefore the solution set is written as x is such that x is less than or equals to b, because b is using the square brackets. So for the number line, so on top of b is a closed circle and left side arrow for negative infinity. And you may complete the example. So for this example, we're going to exclude the value of b, and x is such that x is less than b. So we're going to use open circle and left side arrow. The final example of infinite interval. Both start and end with negative infinity and positive infinity. Remember that we use round bracket for negative infinity and positive infinity. And for the solution set, x is such that x is subset of real values. For the number line, we combine both left and right side arrow. This means all real numbers belong to the solution. Now let's learn how to determine union and intersection up to 3 intervals with the aid of number line. The symbol for the operation union is, and the symbol for the operation intersection is. For union we use the word or, and for intersection we use the word and. Union in terms of set is the collection of all elements. Meanwhile, for intersection, it means that the elements that are in both or all sets. Union is the section where at least one line are seen. Intersection is the section where the two graphs or more overlap. Properties of union and intersection for any sets of A, B, and C. The first property is commutative properties. If we have A union B, it is equals to B union A. So does if we have the operation of intersection. The second property is associative properties. We can do the operation A union B, then later we'll union with C. It's the same as if we do the operation B union with C, then later we'll do the operation A union with B union C. And it is the same as if we have the operation of intersection. The last property is distributive laws. If we have A union, B intersect C, we'll do this intersection operation first, then we're going to union with A. It is the same as if we have A union B, then we intersect with A union C. So we may do the same if we have the operation for intersection. Thanks for learning. Sincerely, Teacher 1.